if you try to visualize this, the same thing in like a 2D space, and this is your local minima, and this you can treat as like, it's not visible like in the flat surface, but think of this as like a bowl, okay, a curve in 2 dimension. Now, if you think about that, like this is like a high point when your loss is high, and as you're moving towards the center, you're actually going down. Now, if this is your starting point, your end goal is to reach this point, and of course, the best way will be you just jump there, which is actually not possible. And that's why what we do is we take like these tiny steps, and each of this step is actually going in that direction. Okay, so how big these steps will be, that will be controlled by the learning rate. If the learning rate is too high, you will make like bigger steps. If your learning rate is very small, you will take like very small steps. Okay, and both are not good. So you need like a ideal learning rate so that you do reach that minimum point and you reach on time. Okay, so ideally what happens is it will be like a zigzag. It won't be like the straight direction. You might go in different directions, but eventually you will reach this point. Okay, so what we can do is, this is another term which you should be familiar with. This is called momentum. And if you think about this, momentum is actually taking into account what was the direction in the previous step. Okay, it's not just looking at the current step, also the previous step. And that is helping because the previous step will tell you, okay, where it was going in the previous step, then you know the current direction. So you will take both into account to make decision for this step. So it's called momentum because you are considering the past. And if you will keep doing that, then eventually when you are making a decision at any point of time, you're actually considering the information from all the previous steps, right? Because in the previous step, you consider the previous, and in the previous, so it's a chain. Okay, so that helps because in that sense, it won't be like a zigzag. It will be like a smooth transition as you go from this point to this point. Okay, so it's kind of, so this is like your normal gradient step when you are not using momentum. This is your current, this is your updated value for weight. This is the weight value in the previous step. This is the learning rate, and that's the gradient. Okay. In momentum, what you will do is you will have like additional parameter, let's say alpha, which tells you like how much of the information you should use from the previous step. Okay, so this partial derivative, you can see like this is partial derivative or the direction from the previous step. This is t minus 1 here, and you weight that with alpha. And then again, this is the derivative, same thing for the current location, right? So then you will make this step. So this is called using momentum. And of course, like these days, we have a lot of variations of this, how you can use momentum. This is just a vanilla version of that. So this is just to give you a flavor of like how, what momentum means when you are trying to do learning using gradient descent.